Hey everyone, Morgan here. Welcome to the lab. So, Mr. Navarrete and I are here today. We want to show you the demonstration that I referenced on the first page of the lecture outline for acids and bases. It's called the light bulb demo. Now, before we get started, I need some protection. Always got to practice safe science. Don't go anywhere without your goggles. Kind of like your face masks today, all right? Now, what we have here is a light bulb, except it's not a complete circuit. You see these two blue posts. In order for this to conduct and make the light bulb come on, those two posts have to be joined together somehow. And we're going to be doing it with some different solutions today so that we can talk about electrolytes and the difference between strong, weak, and non-electrolytes. So what we're going to do to start off with is take some distilled water, okay? And I'm going to fill up this beaker with it. And my whole point of this distilled water is just going to be washing. So take this, I'm going to clean off these posts, and you will notice that no electricity is being conducted because distilled water has no ions floating in it, okay? The water itself doesn't conduct the electricity, it's the ions in the water. So, take a beaker here, some more of this distilled water, which you already know does not conduct. Pour some in. Some is a great word in chemistry when you don't know how much you want to be making reference to. And I'm going to add a whole bunch of sodium chloride, okay? And I just want to make sure, okay, I have quite an ample supply of sodium chloride in there. And we know that is a really good, strong electrolyte because that bond is ionic. And the polarity of the water molecules interferes with that bond, and those ions fall apart and they float separately, okay? Now, when I put this here, look at what happens. That light bulb goes on. Electricity is being conducted through that solution, okay? Now, just to keep everything clean, I'm going to take that distilled water beaker again, and I'm going to rinse that off a few times. You see it's still not conducting, so that that salt doesn't interfere with any other part of the demonstration. Now, my next bottle here should look familiar to most of you. It is just rubbing alcohol, or isopropanol, okay? And this rubbing alcohol is covalent, okay? It is not going to conduct electricity because there are no ions that are available in there to do it, okay? So, open that up that way. And I'm going to take a bunch of it into the beaker. The amounts really aren't critical for what we're doing today, okay? Whether just a little or a lot, doesn't matter. Take this beaker, put it there, and you see no conduction. None whatsoever, okay? Now, just to keep things from contamination, I'm going to rinse that off again. You'll notice I'm not sticking my fingers in there. Okay, now, a strong electrolyte, like sodium chloride, dissociates fully. Let's take this now to acids and bases. We have strong acids, we have weak acids, strong bases, weak bases. This is a strong acid, hydrochloric acid. And what I'm going to do, again, get a bunch of it in the beaker. It, being a strong acid, should be fully dissociated, which means it should be a good conductor of electricity. And look at that. Nice and bright. Now you can't see it in the beaker, but there are just tons and tons of ions floating around in there. Some of them are hydrogen ions, some of them are chloride ions. And they are what is carrying the electric current between the two blue posts. Now this bottle, I mixed up some 1 molar sodium hydroxide. Get that in there. Sodium hydroxide has an ionic bond. It should be a strong base. It should fully dissociate the same way the strong acid. Ooh, that's bright. That's so bright I need to wear shades. Okay, look at that go. So both of those are strong electrolytes, a strong acid and a strong base. Wash that off real good. Now, I also have examples of weak acids and weak bases. This is just classic distilled vinegar. This is the same stuff you have at home. This is white vinegar. The reason I use it in the lab is that it's easier to see into it, to see what's going on, okay? At home, I typically actually don't use that one. So, take this, put it there. Now, you gotta look at the bulb. It is glowing slightly, not a lot, okay? It's conducting, but it's conducting poorly. Now, the reason that that's happening is because the vinegar is not considered a strong acid. The acidic component, which is called acetic acid, is a weak electrolyte which only partially dissociates. And my last one here is a weak base, ammonia. This is just typical ammonia that you would buy at the grocery store. Nothing special about it. It's a cleaning product. Okay? You don't have smell-o-vision on that camera phone there, do you? Whew, this smells bad. Ammonia. Now, you're noticing it is also a weak electrolyte. It's a weak base. It's conducting, but it's doing a poor job of conducting the electricity through that. So, let's recap. Things that are strong electrolytes dissociate fully, like table salt, like hydrochloric acid, like sodium hydroxide. Sodium hydroxide and hydrochloric acid, strong base, strong acid. Then we have a weak base and a weak acid with the ammonia and with the vinegar. They only partially dissociate, so they have a very weak ability to conduct electricity. The glow is dim. And for the strongs, the glow was very bright. And for the non-electrolytes, like alcohol, there was no conduction whatsoever. Okay, thanks for tuning in. This is Morgan, signing off.